Questions 11 through 17, consider the following two sequences. Notice sequence A is given in graphical form. Sequence B, we're given a table. So number 11, is sequence A geometric or arithmetic? Explain why. Well, if I look at the graph, is the graph exponential or linear? Well, this graph is clearly linear, and we should know that an arithmetic sequence has a graph that is linear. A geometric sequence has a graph that is exponential. So sequence A is arithmetic. Why is it arithmetic? Because its graph is linear. So it's arithmetic because the graph is linear. Number 12, is sequence B geometric or arithmetic? Well, what is the pattern here? All right, so what am I doing each time? Well, to me, this looks like I'm tripling. 1/9 times 3 is 1/3. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9, so on and so forth. So number 12 is a geometric sequence. So it's geometric because the pattern is to multiply by 3 each time. So it's geometric because the pattern is to multiply by 3 each time. Number 13. For sequence A, describe a way to produce a new term from the previous term. So in other words, what's the pattern here? Well, look at this. I start with term 0. My starting term is 5. Then my second term is 10. Then my third term is 15. My fourth term is 20. So it would appear that my pattern is to add 5 each time. So describe a way to produce a new term from the previous term. So the new term is going to be equal to the previous term plus 5. New term equals previous term plus 5. For sequence B, describe a way to produce a new term from the previous term. So on number 14, what did we say our pattern was? My pattern is to multiply by 3. So my new term is going to be equal to my previous term times 3. Number 15, write a closed form definition for sequence A. So sequence A, remember, was an arithmetic sequence. So the formula for the closed form is f of n equals f of 0 plus or minus d times n. So if I plug that in, f of 0, what's my starting term? My starting term is 5. It's an increasing sequence, so I'm going to choose plus. And d, what is my common difference? What am I going up by each time? I'm also going up by 5. So my closed form definition is 5 plus 5n. Number 16, write a closed form definition for sequence B. So that, again, is a geometric sequence. So here is the formula for the closed form of a geometric sequence. So f of 0, what's my starting term? My starting term is 1/9 times r is my common ratio. What am I multiplying by each time? I'm multiplying by 3. So my closed form is going to be 1/9 times 3 to the power of n. So 1/9 times 3 to the power of n. And number 17, which is greater, a of 9 or b of 9? Explain or show how you know. So a of 9 means term 9 of sequence A. B of 9 means term 9 of sequence B. So the question is really asking which sequence has a greater term 9. Now, I know I talked about this in a previous lesson. Sequence A is arithmetic. Sequence B is geometric. We've already established that. And we've already established that they're both increasing. So the question is, which type of sequence increases at a faster rate? An arithmetic sequence or geometric sequence? And we determined in a previous lesson that it's the geometric sequence that increases at a faster rate because it's exponential. Okay? So which is greater, a of 9 or b of 9? I'm going to write this answer up here so you can see it on screen. Which is greater, a of 9, b of 9? B of 9 is greater. B of 9 is greater. So term 9 of sequence B is greater because B is geometric and geometric sequences increase at a faster rate. So the key is that sequence B is geometric and geometric sequences increase at a faster rate than arithmetic sequences do.